Welcome. So in this lesson, we are going to be talking about place value. Our learning intentions. To understand how place value works in the Hindu Arabic decimal number system. To be able to identify the place value of digits in different numbers. To be able to convert between basic numerals and their expanded form. To be able to compare two whole numbers by considering the digits and their place value. Let's now talk about some theory here. So this is theory about place value. In mathematics, we use a place value system to represent numbers. That means that the place that a digit takes represents its value. So the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are called digits. The value of each digit depends on its place in the number. The place value of the digit 2 in the number 126, for example, is 20. So let's just pause and reflect on that example for a minute. It says that the place value of the digit 2 in the number 126, well, here is 2, and because of its place, we know that this 2 is equal to 20 because it's in the tens column. So that means it's equal to 20. And that leads us into talking about the difference between a basic numeral and its expanded form. So here is a basic numeral. And as you can see, it's just a normal number. A basic numeral is just a normal number. 3,254 in this case. Now, we can write any basic numeral in an expanded form. So any basic numeral can be written in an expanded form. So let's now talk about what this expanded form is. So let's go through each of these digits. The first digit is 3, and based on its place, we know that it's going to be 3,000 because it's in the thousandths column. So that means it's going to be 3 times 1,000, which is 3,000. The next digit that we need to look at is this 2. And we know that this 2, based on its place, is going to be worth 200 because it's in the hundreds column. So that's going to be 2 times 100 is 200. The next digit that we have to look at is this 5. And this 5 is in the tens column. So that means it's going to be 50. 5 times 10 is 50. And then the final one that we have to look at is this 4. And this 4 is in the ones column, so just 4 times 1. Now what we're going to do is we simply plus each of these together. So we plus, we plus, we plus. 3,000 plus 200 plus 50 plus 4 is equal to 3,254. So that is what the expanded form is all about. Let's now work through some examples here. The first example that we're going to work through says, so we're just finding the place value. Write down the place value of the digit 4 in these numbers. So the digit 4 in 437. So 437, well, here is the digit 4. It's in the hundreds column. So it's 4 times 100, which is going to be equal to 400. We then look at the next one here, which is 24,327. Well, this 4 here is in the thousandths column, so it's going to be 4 times 1,000. And that's equal to 4,000. And then finally here, we have 543,910. So we've got this 4 here, which is in the 10,000 column. So it's going to be 4 times 10,000. 1, 2, 3, which is going to be 40,000. 1, 2, 3. So those are our answers there. Let's now go through our next example here, which says write these numbers in expanded form. The first one is 567. So this 5 here is in the hundreds column, so it's going to be 5 times 100. Then we plus, this 6 is in the tens column, so 6 times 10. And then finally, this 7 is in the ones column, so 7 times 1. Let's move on to our next one, which is 2,705. Well, this 2 is in the thousands column, so 2 times 1,000. Plus, I've got this 7 in the hundreds column, so 7 times 100. And then, as you can see here, I don't have anything in my tens column. So if I wanted to, I could write 0 times 10. But 0 times 10 is just 0 because 0 times any number is just 0. So that means I don't write anything at all. I just skip it. And I go on to my next one. I have 5 in my ones column, so it's going to be 5 times 1. So you just have to be really careful of those zeros here. And now I have 75,020. Okay, so that means I have 7 in the 10,000 column, so 7 times 10, 1, 2, 3, plus in my 5 is in my thousands column, so it's going to be 5 times 1,000. Then I'm going to plus. As you can see here, I don't have anything in my hundreds column, so I just skip it. I go to my tens column. I have 2 in there, so it's going to be 2 times 10. And then I don't have anything in my ones column. So that means I just stop right here. That is going to be my answer. 70,000, 5,000, and 20. Which is going to be 75,020. Okay, next we're going to be working backwards. So we're going to be working backwards now. It says, write these numbers given in expanded form as a basic numeral. So they've given us and the expanded form, and we need to write it as a basic numeral. Okay, so the first one here, 9 times 100, that's 900. 3 times 10, that's 30. Then 6 times 1, that's 6. So that means I'm going to get 936. The next one, 8 times 1000, that's 8,000. 3 times 100, that's 300. And then 1 times 10, that's 10. And as you notice here, I don't have anything in the ones column. So my answer is just going to be 8,310. Notice the 0 here because I don't have anything in the ones. Next, I have 7 times 10,000, that's 70,000. 1, 2, 3, that's 70,000. 8 times 1, well, that's just 8. So I'm going to have a lot of zeros here. So it's just going to be 70,000, 008. 70,008. That's it. Then lastly, we have 9 times 1,000. That's 9,000. Plus 7 times 100. That's 700. 7 times 100 is 700. Then 3 times 1. That's 3. So my answer here is going to be 9,703. That will be my answer. So right here, if we wanted to, we could just highlight all our answers. This one is our answer. This one is our answer. This one is our answer, and this one is our answer. So hopefully you feel comfortable with converting back and forth from basic numerals to expanded form. The final thing that we're going to do in this lesson, oh, and it's moved on me, let's just move this over here, is just go through some symbols that is going to be really relevant to us. Okay. So you need to be comfortable with the following symbols right here. The first one you've seen before. It's just the equal to symbol. So the meaning of it is just equals to. An example, 1 plus 3 is equal to 4. Let's give another example. How about 2 plus 3 is equal to 5? So pretty straightforward, equals. Well, the next symbol that we have is an equal to symbol, but with a line through it. What this means is not equal to. Our example, 1 plus 3 is not equal to 5. We could write another example. How about 1 plus 2 is not equal to 7? So when I have an equal to symbol with a line through it, it means is not equal to. The next symbol that we have is what we call an inequality. And what this is, it's telling me is greater than. So this tells me is greater than, and it'll make sense in the example. 5 is greater than 4. If we were to write another example here, we could write 10 is greater than 3. What I want you to notice here is that this symbol right here is always going to be eating the bigger number. It's always going to eat the bigger number. So 5 here is my bigger number, and it's eating the bigger number. So that's how I always think about it. The next thing is we have another greater than symbol here. So there it is. But now we've got this line. And this line here, what this line is doing is telling me or equal to. So it's greater than or equal to. So our example here is 5 is greater than or equal to 4. So that's true. Another true statement would be 4 is greater than or equal to 4. 4 is greater than or equal to 4. So because it's or equal to, this is true. Next, if we have the same symbol but now going in the opposite direction, it means is less than. So here 4 is less than 5. And yet again, what I want you to notice is that it's eating the bigger number still. It's still eating the bigger number. So that's really important for you to notice that it's still eating the bigger number. If I was to write another example, I could write 8 is less than 12. 8 is less than 12, and as you can see, my sign here is eating the bigger number. And then, just as we have greater than or equal to, we also have is less than or equal to. So it's the less than symbol, but now with just that line underneath, which tells me or equal to. So 4 is less than or equal to 5. I could also say 7 is less than or equal to 7. That is also a true statement. And then finally here, we have these wavy lines, which are wavy, they're like squiggly equal signs, which means approximately equal to. So 4.02 is approximately equal to 4. I could say 6.01 is approximately equal to 6. So it means like close, it's nearly there. It's nearly equal to 6. It's approximately equal to 6. Before we go on to going through these examples here, I want to talk about these signs some more. And as I set up here, these signs can be confusing at first, but what you just always need to remember is that the hungry alligator always eats the larger number. So here is our sign here. And the way that you could read this, so this is 67, is that. That is what it is. Let me write that again. There are two different ways of writing this. The way that I think about it is, as soon as I see that the alligator is eating the bigger number, I say 76 is bigger than or greater than, let's use the word greater, is greater than 67. The other way to write this, so I'm going to write or, we could write it as 67 is less than 76. Both of those two things are true. 76 is greater than 67, or 67 is less than 76. Both are true statements. What I really want you to walk away with is that this sign is always eating the bigger number. Okay, let's now just go through identifying these symbols, and it says state whether each of these statements is true or false. First, is 8 equal to 9? Obviously not, that is false. Is 9 equal to 9? That is true. Is 9 not equal to 76? That's true. Is 34 not equal to 34? Now this is a bit of a brain teaser here. That's false. 34 is equal to 34. So the fact that it's saying not equal to means it's wrong. Here, 3 is less than 6. That's true. The other way you can determine that it's true is that 6 is my bigger number and it's eating the bigger number. 7 is greater than 3. That is true. The other way of knowing that it's true is that in this case, 7 is bigger and my sign is eating the bigger number. We come over here. This is saying 4 is greater than 9. Well, immediately we know that's false. We also know that this is false because my sign here is not eating the bigger number. It should be eating 9 because 9 is bigger. So the fact that it's eating the wrong number tells me that it's false. Think about it. If I gave you, a big slice of cake or a small slice of cake, you're always going to eat the big slice of cake, aren't you? Well, I am. Well, and that's what it's saying here. So you can know it's false because it's eating the smaller number. Let's keep on going. This is saying 1 is less than 3. That's true. And it's eating the bigger number. 8 is less than 7. Well, that's false. 8 is not less than 7. And also here, 7 is our smaller number, but yet it's eating it. So 8 is our bigger number. It should be eating this one. Bigger. I'm just going to write bigger. So we're all on the same page. So because it's eating the wrong number, we know it's false. What about 19 is less than 29? Well, that's true. Also, it's eating the bigger number. So that's good. Let's keep on going. I'm going through lots of examples here because I know people do struggle with these. 19 is less than or equal to 23. This is true. Or is it not? No, sorry, that's false. It's false. I'm getting confused now. 19 is greater than or equal to 23. That's false. And as again, it should be eating that 23 because 23 is bigger. Or you could just read it carefully. Don't be like me. 148 is greater than 132. Well, that's going to be true. It's eating the bigger number. 19 is greater than or equal to 19. That is true because it's got that equal to sign there. So that's how we know it's true. How about 36 is less than or equal to 12? Well, this is false. It should be eating the bigger number. What about 144 is less than or equal to 144? Well, this is true because they're equal to each other. So that's true. And then finally, 17 is less than 17. Well, that's false. If there was a line underneath it, it would be true, but because there's not, it's false. Okay, hopefully you found that manageable. I know that sometimes these inequalities can do your head in a little bit. They do me too. Hopefully all that made sense, and I'll see you in the next lesson.